Oh no. But now this thing is, so thank you very much for having us, and I personally are really glad that it happened and that everything worked out. So we had a pretty last minute change of an abstract. It doesn't really change the talk, but I just wanted to make sure that we don't bait and switch people here. Who are here thinking that they're going to hear about everything about ChatGPT? Okay, couple of people. Okay, I'll make sure after this talk to do another lightning talk about important stuff for your productivity as developers with ChatGPT. Okay, so don't worry about it. We'll make sure that you're covered. But it's all related, right? It's all related. We're going to talk about developer productivity, and the updated title, if you wish, is Unlocking Developer Productivity. A dual perspective on best practices and testing. Kind of mouthful. When you think about dual perspective of developer productivity, getting off Twitter is one idea. Having a better coffee machine, it might be another idea, so it will wake you up. Maybe having a noise cancellation headphones also helps for productivity, but obviously this is not what we're going to talk about. We're going to talk about the engineering aspect of developer productivity, something that we'll get to it in a second. So my name is Baruch. I'm Baruch on whatever social media is called or trending this week. Developer productivity advocate with Gradle. I was a developer many years ago, Java developer, so Java community and Java user groups are very dear to my heart. And then went to kind of pivoted to DevOps with my previous company, JFrog. And now we're talking about developer productivity engineering again. Co-authored a couple of books, DevOps tools for Java developers. It's kind of a between DevOps and Java, and Liquid Software on modern practices of releasing software. My partner in crime today is Aleyner at Aleyner on whatever social media is trending this week, and he's a co-founder of a great company called Atomic Jar that has something to do with test containers, obviously judging by his t-shirt, and he will tell us more about that very, very soon. Very impressive resume, being good and finding team in AWS and on Bing.com. I think only Google missed here somewhere, but yeah. No, you good?
I'm good. Okay,
yeah, all right. Okay.
So that passed me by.
Okay, all right. The most important slide of this presentation is this one. If you go to speaking.jbaruch, you'll find a page which is already there, dedicated for this meetup for today. It has the slides already on it. We are recording the video, so we will upload that as well. And all the links for like everything we're going to talk about and everything we just mentioned, it's all there. To make it convenient for you to find it, it's in the bottom of every slide, together with the Ottawa JUG hashtag. You didn't know that you have a hashtag, now you know. You have a hashtag. And the hashtag DP for Developer Productivity Engineering, our handle. So if you praise this talk on social media, go ahead and use all this beauty for our social media glory. Okay, so with that, let's talk about motivation. Now, we used to think motivation in very simple terms. It was a carrot and stick. Carrot and stick always works, incentives generate behavior, all the usual stuff. If we pay people good enough, they will do what we want for them. If we punish them bad enough, they stop doing what we don't want them to do. While this was true and still true in a large part through the entire human history, it's not necessarily the only way to motivate people, especially not people who do intellectual kind of work, developers, for example. It's true for many different professions and many different aspects of our lives. For intellectual work, there are other forces at play. Daniel Pink, who is a great author with tons of amazing books, one of his best is Drive. Drive is the book about the surprising truth, what motivates us, and he talks specifically about how once you bring the money to the level that it's not more of an issue for your basic needs, something other stuff kicks in. And the other stuff is, namely, 3 factors lead to better performance and personal satisfaction are autonomy, mastery, and purpose. Now, all of you are developers, sorry, and you can start thinking about how those autonomy, mastery, and purpose actually make your life better in terms of performance and personal satisfaction, right? So when you think about how do you behave in your daily life as developer, you will actually find a lot of those 3 aspects when it comes to correlation with satisfaction. A couple of examples. When you're a developer, you're in the flow, and your flow is ruined. For example, your build takes forever, and you're distracted to do other things, and then you need to come back to it, and the context switch is terrible, it ruins your flow, and it actually hurts your mastery, right? You are the best self when you are coding in the flow. When you're kicked out of the flow, it hurts your mastery. It has nothing to do with carrot and stick. You won't get paid less because you weren't in the flow for 1 more hour during the day. But you will feel less motivated if that happens continuously. And it's not only you. We did a fairly extensive survey, and you can see that 84% of the people consider a pain point that too much time is spent waiting on a build and test feedback either locally or during CI. Another thing that also goes into your mastery will be something like a flaky test that is irrelevant most of the time, but it always runs last in the test suite and breaks it, and then you kind of need to rerun the entire thing and see what's going on. And this also hurts your autonomy, because this test is something that it's not not in your power to fix. So instead of doing what you want to do, you need to now wander around and see who can help you fix it, debug it, and what's not. 65% inability to easily troubleshoot and determine the root cause of the build, test, and CI failures, including flaky tests. Right? And something that goes again into all 3 of them, autonomy, mastery, purpose, is a slow degradation of performance of your environment over time. Everything is slower somehow. The build that used to be fast is now slower. The test that used to be faster are now slow. The CI is now takes forever. And again, autonomy, you have no idea why. You have no way to look at some kind of observability into it and see what's going on, right? And 59% insufficient observability of analytics on build and test performance and regressions, failure trends, and productivity bottlenecks. This goes into all 3 of them, actually. So motivation has everything to do with autonomy, mastery, purpose, and it has a lot to do with our productivity. For example, and it goes into autonomy, tools and people aren't in my way, right? Just we spoke about. Tools are helping me and not actually harming me when I try to do something. Mastery, tools and processes help me to excel instead of actually doing a poorer job. And then purpose, I want to be productive. When we talk about productivity, productivity is the same verb as the same root as product. This is what we want to do. Productivity has direct relationship to our purpose, because we want to do something purposeful. We need to be productive to do it. The solution for improving our motivation through productivity is one of them, is the engineering aspect of developer productivity that we call developer productivity engineering. The way we define it is through tenets. We have 7 tenets that kind of explain what developer productivity is and what we want to achieve when we talk about that. The first and the most important that we're going to talk tonight throughout the entire talk is foster faster feedback. We need to proactively invest in making developers' local feedback faster. Faster compilation, faster testing, faster validation, faster everything that can give us some kind of feedback of whether what we just did is good or not. Eliminate toil for developers. Toil can be anything that is hurting our productivity and can be eliminated. For example, if you push something, if you create a pull request, wouldn't be nice if the correlated ticket would be transitioned to the right state automatically, instead of you have to go log in into another system and somehow massage the tickets, drag them, change their status and what's not. So this is an example of a toil that should be actively eliminated for developers. Collaborate through effective tooling. When you need to collaborate with your colleagues and you need to express a concern or an idea, how do you do that in the most effective way? Is just telling them what you have in mind the more effective way? Or do you want to send them a pointer to some piece of information that will help them understand what's going on? What will be the most efficient way to collaborate using the right tools? Prioritize automation and eliminate bottlenecks. Well, that's kind of the same again as eliminate toll for developers. We can automate stuff. We are developers. This is what we do. We automate stuff. But we usually automate stuff that is related to our product, right? The code that we write is the code that improves the product that we are working on. But we can also apply the same knowledge to our own processes and our productivity. We can automate stuff in our work that will make our work just be better. What should we automate first? The bottlenecks. Theory of constraints proclaims that if we don't optimize at the bottleneck, it's completely useless. It's like we don't optimize at all because the bottleneck stays. This is true for our productivity as well. If we can kind of observe what we are doing and then see what slows us down, we can concentrate our efforts in optimizing what really matters. Which brings me to the next one, which is rigorous observability for proactive improvement. How do we know where the bottlenecks are? We need to implement something that we already know how to do, observability. Observability was for a couple of years and still is the hottest trend in software, in software operations. Like our production systems are being observed like a hawk because we need to know exactly what happens in production. We need to be able to troubleshoot, determine bottlenecks and what's not. But what about our development process? Does someone observe that? Do we know that, for example, we now have a new employee that works from a location with suboptimal internet connection, and because of that, their build is terribly slow? Is this employee even aware that this is happening? Is the boss aware that this is happening? That his that his productivity is severely impaired? No one knows that because no one checks that, because we didn't imply observability and we really should. Outcomes over output. Your local process generates tons of output. Your build logs, your test results, your everything. Everything is a lot of output. What of this output is actually reasonable outcome that we want to look at and see what's going on? And the last but not least is dedicated organizational mindset. The example that I just gave with the employee that suffers from slow dependency downloading times. This problem is on no one's mind. It kind of just is. If someone thought about it, well, nice. But if no one thought about it, well, it is what it is. This is because no one, or not a lot of companies think about developer productivity systematically as something that needs to be analyzed and then improved. This is changing. We see more and more companies, and the best of companies, actually investing in developer productivity engineering. Your Netflixes and your Ubers and your Lyfts and the companies that really care about how productive the developer are, Spotify and Snowflake, come up with teams that their only job is find the ways to improve developer productivity by means other than buying better coffee machine, by actually implementing developer productivity engineering. So that was nice, but it's time to talk about what you can actually do today. So small developer productivity improvements make huge difference, and it's really easy to get started, and it's also free to get started, or not expensive, right? So one example is better IDE. You all, it's the most trivial example because you all realize that, right? It's pretty obvious that better IDE produces better productivity for everybody, right? So this is why it's there. Obviously, you already do that. Who uses IntelliJ IDEA? Who uses VS Code? That's all. I mean, 100% of people here are covered with great IDEs that make their work much more productive than a Notepad or Eclipse, for example. Or well, VI. There are people who can be very productive with VI, right, or with Vim. Most of us can't. So I don't know how to exit it, so it's easy for me.
I can show you.
Yeah, I know you can. Testing better. Now, so I started with the trivial one. Now we get to other parts which are a little bit less thought of. The solutions are there. For example, for better testing, and Eli is going to talk about test containers in his part a lot, but let's just show of hands who uses test containers. Two people. Who knows about test containers? Who heard about test containers? Couple of more hands. Eli, you have a lot of work to do here.
Awesome.
Okay, perfect. So test containers for testing is what IntelliJ and VS Code for writing code comparing to Notepad. To Notepad, not even for Eclipse. It's Zen night. And Eli will teach you how to improve your productivity dramatically by just using free and open source test containers, right? Sonar. Who heard about Sonar? Sonar Cube, Sonar Source. Yeah, some people heard. This is a tool. Again, it's open, free and open source, but also paid solutions, but you can start for free with any of them, that actually improves your code. It comes with rules that will be enforced to make sure that your code has a better quality and you incur less technical depth. Reasons to use it? Not to use it? None. There is literally no reason not to use SonarCube in your project. It's open source, it's free, just put it there, your developer productivity goes up. Flaky test detection for more reliable tests. Again, there are tools, there are plugins for your JUnit, for Gradle, for Maven that can help find flaky tests. The way they do it is very simple. They just run failed test one more time, or two more times, or whatever we define. Now, the funny thing is that we do it anyway. If we run our build and it fails, and we look at the results and we're like, there's this test again. What do? We run it again. And then it passes. The difference is, what do we do next? Usually we're just, well, okay, it passed, thank God, let's do something else. But this is actually wrong. What we need to do and that will be your organizational mindset and your toil elimination, is to make sure that you do something with the flaky test. You can quarantine it, you can have a notation flaky that you wrote, and what it does, it will skip the test in a short run, but it will appear in your test reports as flaky, and you need to take care of it. There are obviously, you can do it manually, there are obviously automated tools that can do it. So people who paid me for flying here and being here, Gradle, have a commercial offering that one of the features is actually automatic detection and help you with the flaky tests. And in the end of the day, as I mentioned, most of the effort in developer productivity engineering comes down to foster faster feedback. Now let's talk about feedback, what efficient feedback means, and when and what feedback do we expect. The fastest feedback that we expect is our IDE. We write our code, it marks something like red underline, and we know, boom, we did something wrong immediately. Next in the feedback efficiency will be our build. We expect our local build to be blazing fast. Who has build that takes seconds with tests? Probably no one. Minutes, kind of under 10, that will be the majority of you. Build over 10 minutes. A couple of people less lucky among us, yeah. But actually we want the local feedback of build to be almost as fast as local build of our IDE. The reality is not there, but we'll see what we can do about it. CI minutes to hours, we don't wait for CI. And obviously production hours and days, and we don't wait for our, you know what, that would be funny if any line of code you would wait to see it in production before doing something else. That probably won't work. So it's kind of a reverse dependency on distance from developers. The faster, the closer our feedback type is for developers, the faster we expect it to be. Now, the real kind of on-the-nose exception is build. The build that should really take seconds because we're waiting for it, we're actively sitting and staring at the screen, is actually not taking seconds, and that's a bummer. You all know this comic about compiling. Now, this is bullshit if you ask me. It might be fun for a first time, but in the end of the day, most of us will be very frustrated with long build time. It's not fun. We don't play around while it builds. And if we do, getting back then into the zone, getting back into the flow, the context switch, we'd prefer we didn't have this time on our hands. This is not how it really looks like. Instead, this is how it looks like. We are really, really annoyed that the build is slow. Now, build is a pretty complicated domain that a lot of developers don't feel like they need to understand well enough. Well, probably all of you know how to add a new dependency, and most of you might know how to do some basic stuff in your build, but really getting into the guts of understanding the performance implications of your build, probably very few of you do. And that's understandable. No one can know everything about everything. And it's actually a problem with build because to be productive with your build and to improve it, you need to understand it very well. So it is slow. Not only the developers are annoyed, they also don't know why. Now, what is build? Build is project setup, downloading the internet, all the dependencies that we need, artifact generation, it's compilation, it's packaging, whatever it takes, running tests, some tests, and then deploy the artifact either to like local cache or to some artifactory or whatever. Now, what can go wrong? Project setup, downloading the internet, artifact generation, test, and artifact deployment. Everything can go wrong. When it can go wrong? At any time. This is the problem. Build is a complicated part of your work that you don't have necessarily the control, autonomy, or the understanding, mastery, in order to make it work. The build frustrates the developers. I promised you ChatGPT. No, just kidding. I'll give you like better than that. But if you ask ChatGPT of how to build your Maven build, the first idea will be skip tests. Now, you know what? This is crazy. It defeats the purpose of the build. Let me ask you something. Why do we run local builds? We don't need the artifacts. I hope none of you deploy whatever the results of local builds into production for your customers. It's not for that. We run it to get feedback. And if we skip tests, we get less feedback. Why shouldn't we skip compilation maybe? Maybe we can just SSH into our production system and just check, just change the source code over there of our like whatever JavaScript files without any checks at all. Because if we give up on feedback, let's just give up on all the feedback.
That's why I said VI.
Yeah, exactly. That's what you do in VI. You skip all the feedback. So, right, so this is absurd, obviously. We want faster feedback because we are frustrated by a slow build, but we don't want less feedback. We don't want to compromise on the quality of feedback for its speed. What feedback do we want? Like in the, when we look at how our product is getting deployed to production, we know exactly in which stage we collect the most comprehensive feedback. And that will be your CI/CD. This is where the quality checks are the quality gates are the most rigid, and this is where we are going to collect all the feedback that is possible. We're going to check that it compiles, that the unit tests are passed, that the integration test passed, that the code coverage is sufficient, that the linting is passed, our like whatever demands from our code styles, etc. Static code analysis, that we don't have like all kind of stuff that you shouldn't have there. Security, we scan the dependencies, we scan that we don't have any secrets exposed. We actually did static code analysis for security, that we don't have like unescaped, unchecked input and what's not. And then non-functional requirements, we check the load, we check the resource utilization, and we checked for compliance. Now, all this provides the ultimate feedback on the state of our code before it goes to production. This is the purpose of this thing. Now, this is also the ideal amount of feedback that we want at our fingerprints after every line of code we write. CI/CD is great. It's not terrible. It's important. But it's also not great because we don't have this feedback when we need it. There are two types of feedback, asynchronous and synchronous. CI/CD is asynchronous feedback. We don't wait for it. The problem with feedback that we don't wait, that the results are distracting. We get a notification that the build failed, so we need to drop everything that what we are doing and go and fix whatever didn't work in our CI/CD quality gates. Synchronous feedback, like build, we wait for it in the flow. We wrote something, we run our build, we wait for the results, we fix it immediately. And then we definitely pissed off when it's flow. Right? So commit time is the point between synchronous and asynchronous feedback. IDE and build on the other, on the one side, CI, CD, and production on the other. Ideally, if we could take all this great feedback that we collect during CI/CD and shift it left to the synchronous part of the build and make the build fast enough, that would be our ideal, our ultimate, the most productive synchronous feedback that we can get. But it will be very slow. CI/CD takes, as we said, tens of minutes to hours, and it definitely cannot be synchronous. We're not going to stare on the build log for half an hour in order to do something else. What we want to have is maximum feedback and fast. How do we do it? There are two main techniques that we can apply to our build to make it fast without compromising on the amount of feedback that we get. The first is skipping what we can skip, but no more. We don't skip the tests. We skip what we know for sure didn't change. One technique that is built in all the modern build tools is called incremental build. Incremental build, don't build what wasn't changed. If you're going to run now your Gradle build twice in a row, or your Maven build twice in a row, without running a clean build, but just like a normal build, the second one will be blazing fast, because the build will determine that nothing changed, so there is no need to build anything. It won't build what wasn't affected. Now, the problem with incremental build that it relies on produced artifacts. It limits what the incremental build can skip. It's used, for example, it works great for compilation. We have the list of source files, we have the list of compiled files. If nothing changed on both sides, we can skip. But this is also only because we have physical artifacts on both sides. There are steps in the build that don't have physical artifacts on both sides, and we still want to skip if the incomes of or the outputs didn't change. We cannot do that with incremental builds. Another downside is that it relies on architectural decisions. The decisions of skipping tests that shouldn't be affected by certain changes in code is made by analyzing the dependencies between the modules that we declare. But this is a technique which not always can be applied. For example, I have a monolithic application. I don't have modules. Then what? Then every change in every single code line will trigger all the tests possible. Another problem is errors, mistakes can be made. Sometimes, yes, I know that my API shouldn't rely on implementation, but you know what? Sometimes it does. But the build doesn't know about it, and then it won't run certain tests that it should have run in order to make sure that we didn't break anything. What works better than incremental build is caching. Now, caching makes build faster because once you declared inputs of the task and outputs of the tasks, which doesn't have to be files or physical artifacts, those tasks will be skipped if nothing changed between the income and the outcome, input and the outcome. It makes the build faster for everybody because caches can be distributed. If we work on the same project and I take my caches and put on your machine, your build will skip everything that it didn't change because in the end of the day, the results of caching are exactly the same between both of our machines. And obviously, there are tools that allow this distributed and remote caching for everybody out of the box. And it makes the build faster always. And what I mean by that is that even if we as a team work on very different schedules and on very different time zones, and it looks like all the caches for everybody are always different, there is one agent that constantly builds and generates caches that are true for everybody, and that will be our CI. So if we can use the caches from our CI and apply that to our local cache, the changes that someone else did will actually be skipped for me because I use the cache that came from CI that was integrated between the two of us. And it makes all the parts of the build faster because it doesn't rely on artifacts. So every task, being it from out-of-the-box plugin that comes with your build tool, maybe your Gradle or whatever, or it will be your custom task within your own plugin, as long as you clearly mark what are the inputs of your task and what are the outputs of your task, will automatically be cached for everybody always. And this is much more powerful than just incremental building that only works for certain parts of the build which are declared by the author of the build tool, and you cannot add more. Right? And here is an example. This is from one of the Apache Foundation project. So Gradle, we provide our commercial offering that's called the Velocity, used to be called Gradle Enterprise, to open source projects. So for example, one of those or many of those are all the open source projects of the Apache Foundation. And this is their instance. And what you can see here is that, I think this will work. Yes. So the build time on 17 minutes, this was the build time that it actually took. And it actually skipped 14 more minutes of the build. That didn't happen. And that's like 46% of the build didn't happen because of the build, of the cache. And you can see here what happened. So up to date, this is your incremental build. It saved some time, it saved like almost 2 minutes, but definitely not like huge amount of time. The real savings came from local build cache and remote build cache for this project, for this particular project. So the savings are significant, and the incremental build is definitely not enough. Another avoidance technique. So caching is very awesome for the parts that you didn't touch. But you write code, and then there is the question of, okay, I changed something, which tests do I want to run? I want to avoid running as much tests as possible, but only tests which shouldn't break after I change something. Now, how do I know that? The answer is, I don't know, but I can teach a machine. Predictive text selection is a technique that learns what code changes affect de facto. What I mean by that is, it doesn't look at the structure of my project. Instead, it learns iteratively that this type of change makes those tests fail. But not those tests, and not those, only those. And then it skips the tests that it thinks that won't be affected with a very high degree of confidence. So how does it work? We actually have a black box of machine learning that we throw code changes and test results into. We say, okay, those are the changes. We run all the tests. Those were the results. Some tests passed, some tests failed. For those changes, those are the test results. Some passed, some changed. And we do that a lot for a long time. After a while, the model emerges with an outcome. It starts predicting which tests will fail and which test will pass for a certain code changes. Right? So we throw into what changed and where it changed, and then we correlate it, the machine correlates it with the observed test failures, and then it predicts which changes will fail which tests. Now, the science behind it was developed in meta research and Facebook research, and there is a paper about it that you can go into speaking at Baruch and go to the show notes page and see a link to this research. And if it's something that is interested you, I am suggesting you read it and see how it works. Now, a couple of examples of the conclusions that this model come up with. For example, the more tests a project has, the less they break. Now, for us, we reason as humans and we say, well, yes, better test coverage usually means that the developers will know sooner enough that they wrote something bad, and even before they commit or run tests, they will fix it. So for us, it actually makes sense. The machine has no reasoning. It doesn't know. All it knows is correlations. The most tests there are, the less they break. And we're like, okay, this is interesting. You came up with it by not applying reasoning, but it actually matches with our reasoning. Another example is refactoring in Java break less tests than refactoring in JavaScript. And we go like, duh, obviously, because it has what is called strong types. So obviously, when we do refactoring in our IDE of IntelliJ, it does better job than for loosely typed languages that it has no idea what to rename. So for us, it actually makes sense, but the machine has no idea why. All it knows is that if this is observed, those are the results, this is the conclusion. So this is very nice because it actually proves that the model actually works. And the results here are also profound. So another free instance of an open source of the velocity for an open source project, this is Spring Framework. They run simulations, and you can see here the accuracy. So simulations of 4,400 builds predicted with 99.4% accuracy the results of the test, the failures. It actually only guessed 2 times incorrectly, assuming that the tests will pass when they actually broke. 2 times out of 4,400. And almost 96% tests, individual tests. Now, when we talk about, okay, how much time it saves, so this is over a week. Over a week, it saves almost a week of work of a particular developer on the Spring Framework team. Wow. And it's actually like avoidable tests, it's almost 40%. So they skip almost 40% of the tests and run only unavoidable 59% of the tests. Now, you can be worried about those 2 tests. Because, you know what, maybe they're very important, maybe we broke something very, very significant. But remember, we are talking about local feedback, synchronous feedback. This is useful for when we run our Gradle build or our Maven build after we change something and we wait for the results. Now, we saved tons of time. We sacrificed, what, less than 1% of accuracy. that will be covered anyway during our CI/CD. Because we run everything in CI/CD. There is no reason, no one waits for CI/CD. It can take as long as it can, as it wants, and run all the tests in the world. We actually want it to happen. Yes, in like 2 tests, in 2 times out of 4,400 times, we will be really annoyed, like really annoyed. Our test, local test passed, and then we got this notification that CI failed. This is like, oh damn. But it's so rare that the benefits for our productivity in running 40% less tests is overweighted by a lot. So this is actually, although not perfect, a great way to improve your productivity and avoid running unnecessary tests in your local environment. And that's again, is something that Gradle provides inside the velocity, right? So, okay, so we now avoided everything we could avoid. We avoided everything that could be avoided with caches. We avoided everything that could be avoided with predictive test selection. There is work to be done, period. Okay, we change something, we have to run tests. There is, I mean, okay, we have to. How can we speed up what cannot be skipped? First is test parallelization. You can use your max power of your local machine to run tests faster. And this is why your boss should buy you the bleeding edge of hardware. And if you want this meetup to pay for itself, you just take the next slide that I'm going to show you, take it to your boss, and your boss will buy you the next M3 whatever MacBook Pro that due to come out in the end of the month. Because, look at this. This is a test on my machine. This is M2 Pro Max, whatever. I have a project that it has 2 minutes to run tests. 1 minute 59 seconds. And then I change one line of code in my build, and now it runs the same tests in 10 seconds. 12 times faster. The only thing that I did is I said, use all available processors to run tests. 12 times faster. You take this to your boss and you're like, hey boss, you have to. And they're like, well, I cannot argue with numbers. 12 times is 12 times, right? Here we go. Now, not only we can use the power of our local machine, we can also use the power of the cloud for that. This is not new. There is a process called CI fanout that CIs employ to run tests in parallel. Now, it works for CI, but shouldn't you also enjoy it for local tests when actually the feedback time is much more important? Who cares how long CI runs? Local, I want to make it as fast as possible, so I need to use all the tricks to make it faster. You can use the cloud to distribute test load, and then you run all the tests, all the relevant tests. You already skipped everything that can be skipped. So you skip no more, but instead you run them faster. You can rely on your CI, or just, you know, I heard like, well, I just push it and then let CI run tests. But again, you miss the local feedback. And if you rely on CI, you actually can use the same CI infrastructure, which is not optimized for real-time feedback. CI agents are not as fast as they can be. They might not have caches, because who cares? They might not have the strongest machines, because who cares? For local development, this actually matters. So when you use test distribution, you run it on a very strong hardware, which is optimized to run tests, because you need the feedback back as soon as possible, right? And you can actually use a combination of test parallelization with test distribution to get even better results when the velocity will decide for you which tests should maximize your local hardware and which should be distributed to the cloud, right? And the last aspect that we spoke about is don't let it slide. The observability and the continuous improvement. We start with, again, something very, very simple. Measure record, and track local build times. Your productivity depends on it. Across time, across different environments, how is your build at home? How it differs if you go to the office? Maybe you have a virtual environment that you sometimes run the build. How does it run there? Is it faster? Is it slower? And and then watch for down-facing trends. And when you find the down-facing trends, you actually go ahead, find root causes, why it becomes slower, and improve. And you don't need any tools for that. You don't need to pay anyone any money to do that. Just record local times, draw them in the Google spreadsheet, and then plot graph. But if you want a tool that, again, is made for that, this is a graph from the velocity again that shows you this is boiling the frog. It creeps on you. It gets slower a little bit week by week, and then you actually, everything is slow. But if you have that, you can monitor it, and then from here you can go to each and every build, see why it's slower, compare it with the same build week ago, see what changed, and actually improve. So now let's talk about even more how we can speed up the test that we have to run after we already avoided everything that can be avoided.
Awesome. All right, anybody else here is excited about testing as I am? Oh, there we go. Awesome. All right, let's talk about tests, right? So Baruch told us all about build. He told us about which tests we should run, but let's actually talk about the tests. And what are the trade-offs that we have when we talk about tests? There's really two trade-offs that we all live with today, right? We can have expensive, slow, and production-like that give us realistic feedback, or naive, useless, but fast. Awesome, right? Yeah. I mean, the reality is of today's world where most of us live in, right? We have the choice is very simple. We do unit testing with mock services that are really fast, that you can run locally on your machine, that produce outcome that is wrong, right? Because they just test business logic, but they don't test anything else. Or we can go and do things like staging environments, right? We can deploy software into some kind of an environment that reflects production, right? But it's expensive and it breaks down over time. And the more we use it, the more it breaks down. And I'll talk about it in a second. There are also people who go directly to production. Anybody here? Test in production? VI, there we go, VI, there we go. Baruch talked about that. YOLO, you only live once. It's awesome. You should do it, but your job might not. Thank you for it. Yeah. So I'll tell you a story, right? So Baruch mentioned that early in my career, I was on the S3 team at AWS, the launch team for S3. And, building what ended up being the storage for much of the internet at the time. We're like, okay, so we're writing software, we need to have some kind of confidence of how we're gonna roll this software into production and make sure that the software that we have out there is actually good. We're like, okay, great, we're gonna do integration tests, right? We're gonna deploy them to a staging environment, what today we would call using a CI tool, right? At the time we wrote it all ourselves. And we're gonna run those tests all the time. And we're like, okay, but we need to know how good we need to know whether the tests are passing or failing, and we need to, we need to make sure that the team pays attention to this when they start to fail. We're like, okay. So our manager at the time comes up with a great idea. They're like, okay, great. S3 team at the time was fairly small. They're like, okay, we're going to put monitors around the area where the team works. And we're going to put the status of our test of our integration tests over there. And they're going to be, green, yellow when they were flaky, and red when they were failing consistently. And they put the monitors, but nothing really happened. Because, who pays attention to failing tests? And then they did something that was quite ingenious. As opposed to just the test results, they showed us a picture of a bunny. Right, and that's a famous S3 bunny at the time. And the bunny would be happy-go-lucky, like the happiest bunny in the world, if 80% of the tests were passing. That was slightly earlier, this was slightly simpler times at the time, a little bit less politically correct. The bunny was very unhappy, a little bloodied, when less than 80% of the tests were passing. And the idea was, hey, if the bunny is hurting, we have to go and save the bunny, right? If you walk around the area where we worked, if the bunny is not healthy, you have to drop everything and you have to go and save the bunny, right? But the reality is, one of the things that we learned, and one of the things that I've observed being on the street team, is that over time, the bunny became much more depressed. The bunny spent a lot more time in the state of unhappiness, because as we progressed in the project development lifecycle, what happened is that we had more tests, and we had more flakiness, and we had more issues. And when I go and I talk to teams, modern times, I see the depressed bunny problem all the time. If the only place we're going to get realistic feedback is going to be in staging environments, which are susceptible to, data, deployment issues. We have environmental issues. Someone could have rolled something out. We have tests that depend on the same data sets, right? So tests might be flaky because somebody else tested with something else and now the data is slightly off. So okay, what are we gonna do? And this causes I don't care syndrome. Anyone experiences that I don't care syndrome? There we go, all right, there we go. We have lots of people who's, and the reality is, as soon as you start experiencing the I do not care syndrome, you get into a position where the value of your testing harness actually decreases, right? No one pays attention, right? And the amount of time it takes to keep that environment running and producing any kind of feedback actually increases, right? So value decreases, amount of time it takes increases, people don't care. And it's a self-fulfilling process. It happens every time. Every single project I observe happens, it's just a question of time. It's not if, when, it always happens. And there are lots of different approaches, and people look at it through if you're gonna do faster horses, we're gonna do more environments, we're gonna deploy it better, faster, still happens. We still get to the sad bunny and depressed bunny problem. I see it over and over and over again. What we want, right? Developers want production-like and fast. We want something that, I can run on my machine, I can get this feedback that is now, I'm only able to get it out of my CI/CD that is, as Baruch told us, asynchronous. I want that feedback synchronously. I want that, you want it too. Oh no?
Yeah, I was just going to add, one main reason why things were not getting fixed in the production environment that I saw was that people always thought, well, the build is, the thing is broken, but it's probably not me.
Of course! The I don't care problem, syndrome, awesome, yeah.
So, if it's not me who caused the problem, why should I?
Of course, it was flaky before. This happens all the time, right? And it's production, it happens over and over and over again. And as soon as you start running into this, it spreads. As soon as your testing harness, as soon as this happens, people what develops is, it's not my problem. It's not me, somebody else caused it, I deployed something, it's a data issue, let's run it again, right? Baruch told us, if it's flaky, let's run it again, maybe it will pass. Maybe it will, maybe it won't, but let's wait for it to run one more time. As developers, as Baruch told us, we want faster feedback. We want realistic feedback, and we want it as quickly as we want. And ideally, we want it synchronously. That graph that Baruch told us, the distance from the developer, we want to bring some of the feedback we're getting from CI much closer to the developer. I believe, and I'm gonna argue with you today, that self-contained tests are the answers. Self-contained tests are tests that are real, they're not just mocks. They don't depend on any centralized environments. They have no interdependency on tests. They bring up all of the things that they need to test. They test them, and when they're done, they blow it all away. Tests that are that can run on your machine, tests that can run on your in your CI, tests that can run anywhere else. Tests that the particular project that I'm going to talk to you about today actually make writing much simpler. They make creating self-contained, idempotent, repeatable tests much easier, and they allow for clone and run scenario, where you can just clone a project, run it, because it will run, because it depends on nothing else. All of the dependencies that it needs, it brings with it, and it's able to spin them up. But how? Test containers is the answer. I know I spoiled the surprise over here, but I'm going to do a demo, right? This is a Java user group meetup, so I'm going to show some Java code.
No,
No?
we need to.
Okay, we need to switch around. There we go. All right. Can anyone see my screen? All right, awesome. So I have a simple application here. This is actually an abstract class over here that defines, hey, my application is going to need Redis. Give me an instance of Redis. Give me an instance of Kafka in order for my application to run. Give me an instance of Postgres. In my code, no containers, no YAML, no Mambo, none of that stuff, right? Then I do a simple setup over here, which is, hey, I'm going to need the host name for my Redis. I'm going to need the Bootstrap servers for my Kafka. And I'm going to need the Postgres environmental variables. Then what I can do, I can have a full integration test, a full application test that extends that abstract integration test class that actually spins up my application that uses Kafka, Redis, and Postgres and starts issuing requests against it. What I'm going to do over here, I'm just going to YOLO it and live and show you what happens when this runs. This is a Spring Boot application, as some of you might know. And what starts happening over here is in the output, you start seeing Redis, Kafka. You start seeing actual dependencies being started up over here. Data is going to get populated into them, and then within seconds, which you're going to see, the test is either going to pass or fail, 50-50 chance, right, Baruch?
Always.
There we go. There we go. In this particular case, the test has passed. So what I've had over here is I've had a test that is, realistically, an integration test that ran in this particular case, on my local machine without relying on anything else. It spun up the dependencies, it ran it all locally, and was able to execute in 5.6 seconds over here, spinning up all of those fairly sophisticated technologies. And it's not limited for just Kafka, for Postgres, you can spin up Oracle, you can spin up many of the cloud providers have modules for their services that you can use as well.
Two things. I didn't see where the database was loaded. Is that in the code as well, or is that like
the database is defined over here. It automatically gets wired in.
Okay. And then the second thing is.
You mean the actual data in the database? There is a
test data.
Yeah. I can show you the actual file where it lives.
Sort of like just a bunch of SQLs that are getting loaded.
Yes, I was gonna say, like there's like the installation and then loading test data.
Yeah. No, so there were always ways to kind of do that, right? You can always spin up a DB2 in process and then load bunch of SQL statements and then test against it. The problem with it that databases are different, the SQLs are different, and what you're going to load into your in-memory process will be very different from what you are doing in production. With test containers, you can actually pick the exact flavor of the database that you are using in production and use the exact data as it is in production to run the test across it.
And Yes, so you can also use Flyway migrations, another tool to actually load data into the database instance.
Something like that along those lines. The second question is, how would this integrate with, like, if you want to do like full stack? So if you have like also the front end.
You can load anything with this. Yes, there is a Selenium module. So you can spin up a container that will have a browser inside of it, and you can have it do the testing for you. You can spin up your own containers. It doesn't have to be a particular technology. We have people who are doing, people doing A/B testing. We have people who are doing canary deploys. New version of one service, older version of another service. They spin up test containers and do the testing against it. Actually, that's a use case that Spotify uses in particular. So this stuff has been around for quite some time. Test containers as a technology started just a year after Docker containers started. Up until a couple of years ago, there hasn't been a commercial company behind this. It was presented in conferences primarily. Now there is a commercial company, and I'm going to talk a little bit about it. But this stuff is quite mature. We have I'll switch back to Baruch, your machine for a sec, and continue with the presentations. But we have over 50 modules. There's 50 different technologies out there. The technology, give me a sec. There is also a plugin. I'm actually going to go back and forth. A sec.
Faster feedback.
Exactly.
Faster feedback for out.
Yeah,
there we go. There we go.
Almost. Technology is hard.
Yeah. Next time we'll use one machine.
Yeah, next time we definitely should use one machine. Actually, there is no reason not to.
Yes. Let me do it again.
Yeah, okay. There we go.
If it fails, you rerun the test.
It's a plug and pray.
Yes, plug in and pray.
Plug and pray. Yep. Come on, it worked. What's going on?
It worked once. All right, I'm going to
It
continue.
worked more than once.
Okay.
Yeah. Okay, we'll try it again. Scanning all sources. You don't need all sources. You need HTML 1.
I'll just continue going and then. Oh no, there we go.
Yeah, no, we're almost there. We're almost there.
Can I ask you a question?
Absolutely.
How do you measure the effectiveness of test containers? And do they tend to vary those metrics based on what application you're designing for? Or are they...
Measure effectiveness. Elaborate a little bit. Measure effectiveness again versus what? Like, I mean, the reality is how quickly you can get feedback from the. What we're striving for is for fastest possible feedback and most realistic feedback, right? When we talk to many organizations, the same feedback that Baruch talked about, the synchronous feedback, the CI can take from minutes, sometimes 15 minutes. Usually, people count it in number of coffee trips they can do, right? So the question is whether you can get that feedback synchronously on your machine even better before you commit your code, right? So if you're able to shorten that feedback cycle by orders of magnitude, you get productivity, right? You get realistic feedback. You get much faster, Okay, there we go.
We're doing
Baruch is doing the magic behind the scenes. So yes, I mean, the question is, what do you compare it to? Can you get the same realistic feedback? There's other ways of getting it. Like realistically, people have stood up some local type of an environment locally on their machine, oftentimes using Docker Compose, right? You would spin something up, and you would test it, except it doesn't live with your source code. It doesn't have the same lifecycle as your source code. It is independent, and then everybody else has something different, and you need to spin it up, hope that it's in a good state, and then run your test against it, and then spin it down. This brings all of this right into your same code base. It's repeatable, idempotent. Every single time you run it, you get exactly the same output. All right, there we go, Baruch.
But no clicker for you.
Oh, no clicker for me. All right, I'm going to do this. All right, so this, I've talked about this, that this has been around for a while. There are actually public cases of this being used by Netflix, by Spotify, mentioned last Friday. they gave us $25,000 in their open source investment fund for test containers open source technology. Netflix talked about it extensively. Uber has an article of how they solve the flaky test issue with test containers, and particularly DoorDash, many others. And this is available for a variety of technologies. I've talked about that you can use test containers with over 50 modules. You can do it with every single technology that can be deployed in test containers. In a Docker file.
No, you go ahead.
Okay,
Trying to improve your productivity here.
There we go. Thank you. And with coffee machines.
Without coffee machines.
Awesome. Cool. All right. So, and while today I'm going to talk about Java, the same test containers technology is available in Node. It's available in Rust and .NET. We have over 8 languages that those libraries are written in because the pattern is very much similar. We've been investing in it for some time. So what I talked about up until now has been completely free and open source. You can start using it tomorrow, like it's testcontainers.com. You go, you download libraries. It's awesome. But we can do more. Right? So we've talked a little bit about self-contained tests that get spun up. They get spun up. The dependencies get spun up on random ports, so they don't collide with anything, and they allow you to do this iterative loop much faster. What we've been doing over here is we've been looking at this, at the same GPE pillars that Baruch talked about earlier, and yes, we help with faster feedback, but can we go even further? Can we go into helping you debug even further, helping you get even more observability, and so on and so forth that. And we concentrated on a couple of use cases. So the first use case we talked about is how do you get more visibility from your tests? How can you debug things a little bit better, right? We've just a few weeks ago released Test Containers Desktop, which is a free application that you can go and download from testcontainers.com that, as opposed to, so with open source, it spins up containers, tests against them, and then when you're done, shuts them down. With Test Containers Desktop, you can say, hey, freeze a container, shut down. Don't bring it down. I want to be able to log into this, and I want to see what's inside of it. It has service configuration, so you can say, hey, look, Test Containers spins up containers on random ports. My tooling expects containers to be available on a particular port. I want to be able to forward my ports over to that. I can reuse containers, and as a small bonus, we added embedded runtime. You can run it without having Docker desktop on your local machine. I'm going to do a small demo over here of this in a second. It's comfortable that I no longer have to switch machines over here.
You need to exit presentation mode in PowerPoint. Almost. Still more comfortable than having two machines.
Yes. I will do that.
Yeah. Now.
There we go. Now I have this. Awesome. All right. So ratings controller. So now on this particular machine, I have Test Containers Desktop installed. I'm freezing containers shut down. I have it configured to forward my ports for Postgres. And what I'm going to do over here, I'm going to run this test. But now I'm going to run it in debug mode and actually have a breakpoint over here. So now it's going to go spin up all the same containers. Right. Huh?
Did you remove the breakpoint?
No, the breakpoint is there. It's going to stop at that breakpoint. There we go. I'm at that breakpoint. Right. So now I'm at that breakpoint. What I can actually do over here is I can go into here and I can go into services and I'm like open terminal. What this is going to do. So now I'm logged into that particular container. What I can do is psql -u test. Live. What's happening? Assume test. There we go. I can do -d. I can see all the tables. I can deselect star from talks. What? Why can I not select live demos from talks? Did I? There we go. I can see all the talks that are in my database instance right here. So what I was able to do, I was able to suspend execution. I was able to log into that particular container that is running, and I was able to go and actually debug the actual data that is in there. It's not shared with anyone, just mine. And as soon as I continue the execution, it will finish and it will wipe down those containers. I can do it all over again, time and time over again, right? So going back. So that test containers desktop, and then there we go. I talked about the demo, but I can go even further than that. I can work on consistency and repeatability and scale of those outputs, right? So as opposed to running it all locally, what I can also do is I can have the backend for this to be a cloud service. So as opposed to spinning up those containers locally on my local machine over here, I can go and spin it up in the cloud. We have a test containers cloud service that solves the Apple silicon versus Windows versus Intel silicon, because now it becomes consistent because it's the same backend. It solves the Docker and Docker issue in CI. So if I'm running test containers in a containerized CI environment, I no longer have the Docker and Docker situation. We have turbo mode for parallelization, so we don't necessarily have to give you one machine where your containers are going to run. We can give you multiple machines. So if you start running it, we can give you a whole bunch. And we can give you team and enterprise-wide visibility of test containers usage. Things like dashboards where you can start seeing like, hey, this particular test run, here's the containers that it ran. You can start seeing across my organization, my team is testing, my teams are testing with Cassandra 3, we're trying to move to Cassandra 4. All of the tests are happening with that particular dependency. You can start seeing what type of week, months, people are doing more testing and so on and so for that. So we have a little bit more visibility with there for larger companies and enterprises and all of that. And it all works with, you know, an encrypted tunnel that runs from your local machine over to, we have a distribution, we have edge locations in 30 locations around the world that enable you to have a localized experience and spin up those dependencies ephemerally for what you're trying to do. So I hope I convinced you that test containers is also DPE and helps enable better developer productivity. And there are multiple ways of looking at it. One of it that Baruch has presented, one of it that I've looked at, I've talked about today. Both of them actually work very well together, and we have customers that do both of those things together and talk about this. Hopefully that was useful for you.
Okay, so kind of to take it back home and to show you a little bit of results, what's happening when you actually start doing all that. Well, back to our survey, among the people that are already doing developer productivity engineering, 84% of them agrees that it improves productivity significantly. Right? Almost every surveyed organization agreed that since integrating developer productivity engineering practices into our development process, the time savings we experience on build and test cycles have dramatically improved developer productivity. And this is my favorite slide of the entire presentation because it speaks about developer joy. Recall first time you actually did some computer programming. You did it and you were like, wow, something happened. I created something new from nothing. Right? It was joy. It was pure joy that unfortunately majority of us lost when we first encountered like IBM WebSphere or something. Did it come back? Maybe a little bit. The industry got a little bit better. overcame the trauma of J2E, but in the end of the day, DPE is another step towards bringing back the joy, right? So, speaking.j Baruch, this is where you go to learn more. Yeah, that won't work. To learn more and also try some stuff today, you can scan this QR code, it takes you to the same place. And then what you can do there is speed up your Maven or Gradle build right there. And if you're afraid to do it on your production build or whatever, we have some ideas of open source projects that you can play with and see if the gains. DP agent of change. If we manage to convince you today that developer productivity engineering is important, you can use our advocacy platform to actually get tools to convince your organization to embark on the developer productivity engineering journey and have some very cool swag along the way. We love our DP agents and we treat them with a lot of very cool swag. DP handbook, it's also there by Hans Doctor, the co-founder of Gradle. DP Summit was a month ago. The videos should be out any day now. I think next week, realistically. There are tons of great content from all the who's and who's and the celebs in the industry about how they do developer productivity engineering, including our mutual friends from Netflix who are talking about how one of the most important pillars of their developer productivity engineering journey is test containers. And with that, thank you very much. I'm J Baruch, this is Aleyner, and this is Ottawa JUG, the new shiny reborn and looking better than ever. And we're talking about DPE, which stands for Developer Productivity Engineering. Speaking.j Baruch, the slides are there, all the links are there, the video will be there soon. Thank you. We have no better place to be than here, so if you have any questions, we're here. Yep, go ahead.
I think it's really cool that you show a console of the test container desktop, and then you go into the write SQL command in a directly. So I was wondering, is the SQL command line being executed in the SQL that's being walked in, or you have the SQL actually running on the network?
No, what I showed you is I spun up a container and I logged into that container. That actually ran Postgres. So the container actually had a pSQL that was installed on it, and I was able to see what's inside of it.
The container is having a PostgreSQL in it?
Yeah.
Oh, I see. So it was exposing the port on the container port.
It was exposing port on the container port, and I was forwarding, and I was able to log into it.
All the functionality that Postgres have here.
Yeah.
So cool. Thanks.
It is cool, yeah.
So to run test containers locally, do you just need Docker Desktop?
You can use Docker Desktop. You can use Test Containers Desktop with embedded runtime on MacBooks. We're still working on Test Containers Desktop on Windows. It will come soon as well. Okay. But you can run Rancher Desktop. You can run Podman. Yeah, basically, as long as it has a Docker API, it'll run.
And then does test containers run within a container? I know you said Docker and Docker is not possible for
No, it's possible. It's just
environment, right? And you want to run the CI pipeline on a pod. Can you deploy test containers as a container?
So how you deploy it is up to you, right? So you can absolutely deploy it as a container. The challenge in containerized environments, so if you run in Tecton, if you run somewhere which is containerized to begin with, when the test runs, it's gonna try and spin up another container. If you have a Docker daemon there, great, it will use it to spin up the container, it will run, awesome. The challenge there is that most people expose Docker and Docker, which is insecure, right? So yes, you can do it. It will work. It's just unsecure. Test Containers Cloud enables you to have a simple agent that says, hey, when you need to spin up another container, from your containerized environment as opposed to spinning up locally. It will give you a machine on the internet that will spin it up for you. It will use that machine, and when you're done, blow it away. So that's all it does.
And it handles the dynamic endpoints.
Yeah.
The cloud.
Yeah. It's completely it's transparent. It's transparent for when you're running the test. All it does is that when it needs the dependencies, it gives you a secure tunnel to a virtual machine in one of our edge locations in the cloud that spins it up for you.
Gotcha. So the API covers like
The code that you do, so the beauty of this whole integration, this test containers desktop and test containers cloud, is that the reality is my code did not change. All of the code that I had running on that machine was open source code using open source test containers. There was nothing proprietary in that I've done over there. All of the things that I've done on top of it, and this is how we think of the company, we do it for the test containers community, we do it for people who use test containers. Today, you can start using our tooling, test containers desktop or test containers cloud, to improve your experience with using test containers already.
Cool, thank you.
Yep.
If you don't have test container desktop yet, because it's only on the Mac right now, you run your test.
Test containers Mac actually. Sorry. Sorry. Please finish your question and then I'll reply. I apologize.
If you hit your breakpoint, like in the example that you had, you spawn a container, you press, you hit your breakpoint, and then you want to debug, but you don't have test container desktop. So you need to use a SQL client. Like my question is about port management.
So I'll answer your question. So test containers desktop does exist on Windows. It does exist on Linux and others. What does not exist outside of Mac right now is the embedded runtime. So on Mac today, we give you the optionality of running it without having Docker desktop or Rancher or anything else. That still doesn't exist on Windows. So you have all the same functionality, including the ability to spin up those containers either locally on Rancher, Docker desktop, or up in the cloud through Docker desktop, so through test containers desktop, either on Windows, on Mac, or anything else. Yep.
So I've got two questions.
Great.
The first one, is it only Docker that's supported, or is it does it also work with Podman?
Docker API.
Only Docker. Okay.
Docker API. So Podman, yes, work. I mean, the reality is that most of the Docker implementations out there use test containers to do testing for how well they support the Docker API right now. So Podman does work, but it's up to them to bring up Podman to complete compliance with Docker API. We have heard of some use cases that have failed with Podman in particular. But we in the Podman team are working on this.
Okay. And why is Docker and Docker insecure?
Because so the way containers are implemented, the way container security is implemented, it's not a full virtual machine. You're not completely isolated. So virtual machines rely on a hypervisor that provides complete isolation. Docker and Docker, you're actually sharing rootfs, as far as I understand, between the two containers. You actually don't have any realistic boundaries between the two containers. The container that is spinning up, and you need to be able to run it in root mode, if I am correct. So basically, if you want to have any type of security, if you want to have any type of software supply chain guarantees, if you want to make sure that what you're doing is one thing cannot interact with other, Docker and Docker is particularly a bad idea. Second question? Oh, this was it? Okay.
Okay, so as I promised you, ChatGPT, right? So 45 minutes, here we go. No, I'm just kidding. Actually, this talk, we spoke about most of the things that are covered here. It's just the fun way to present the same ideas, although it has it also touches about how to be more productive when you work with ChatGPT, and this is the part that I want to show you. I'll go through the entire of it. It's 17 slides, so it's not a big deal. Right, so you saw this. I told you it's going to be quick. You saw this. It's going to be quick. And okay, so the premise of this talk was, and I'm not going to show you the full just because it's starting to get late. I actually asked ChatGPT questions and did what it told me to do. So it started very nice with questions about what is developer productivity engineering, and it actually told me the right thing that you know by now. And then why do we want to improve it? And it told me the right thing that you already know by now. And then what can be improved, and it actually spoke about like faster feedback and what's not. Like, so just as to summarize, developer productivity engineering helps us improve overall developer experience. The build is a good place to start, right? That's exactly what we spoke about. And then it's not only Gradle, Maven, SBT, Bazel, and any other build can and should be improved. And then it's not only the build, improving the entire cycle, including tests, is important and worth investing, right? So this is what like that, actually the summarized answers of ChatGPT. It was fun, but then I actually pushed it to actually tell me what to do in the code. So I have a project example, the same project that with the test that run for 2 minutes and then run for 10 seconds. And I'm like, hey, ChatGPT, tell me how to improve it. And then it started like hallucinating like crazy. And most of the code that it suggested for me was completely wrong, right? And I mean, for some reasons. So generally, there is a cutoff date. ChatGPT is trained on the internet as it existed in September 2021, and for ChatGPT 4 for January 2022, which a lot of changed in that. What is developer productivity didn't change. This is why the abstract questions were spot on. But when we actually got to, hey, give me how to do it with the latest version of the Velocity and Gradle, it was all bullshit because the latest version for ChatGPT was 2021 when there was no even a project called the Velocity. It was called Gradle Enterprise. So that was a disaster. The way to work around it was enable browsing. So for a time, for like I think half a year, ChatGPT had access to the most up-to-date internet through browsing. You could enable it and then say, hey, check official Gradle documentation and tell me how to do it. And it actually used that. Now, as usual, we cannot have nice things because people suck and they do nasty stuff. So this the browsing was abused for stuff like DDoSing and overcoming paywalls and what's not. So they killed browsing. And there was no browsing for a while, and they actually brought it back in September, like a month ago. But they tried very hard to do tons of protections around it, so you can't abuse it, so it doesn't work half of the time. It tries to browse to a website, and then it's like, ah, fuck it, I don't know what's going on, I give up. And it goes back to actually the results of the results of as of December 2021. Now there are third-party browsing plugins, but they are kind of picky. They're very oriented for a specific domain, and I didn't find a good browsing plugin that is dedicated for IT. So that's unfortunately not a solution. Another reason why ChatGPT is getting awarded, it's not here, and I should probably add it, is that there is a theory that OpenAI tries to save money by provisioning partial models and then give you the model that mostly fits your profile as they understand it. So I asked what is developer productivity engineering of ChatGPT every Tuesday and Friday. So it kind of knows that I'm into developer productivity engineering. So if OpenAI can provision me an environment that can answer those questions, and not necessarily questions about how to grow lettuce in the winter in Norway, they can save some money. Now the problem is obviously it reduces the overall quality of the model. Because sometimes I want to ask about ladies and it won't be able to answer that, so that kind of sucks. So yeah, now what we really want to do in order to improve it is to provide it with the information that we want the answers for. And me, as I work in Gradle, I want to provide it with information about up-to-date Gradle documentation. And the way to do it is custom embedding plugins. Now, the way it works is we set up a vector database, and basically a vector database is a database that knows how to massage the information that we give it for machine learning. Basically breaks it into vectors, which are collections of tokens, which are basically separate words, right? So, and then once we set up a vector database, we feed our custom data into this vector database. For example, I can feed it with all the documentation of Gradle build tool and all the documentation of the velocity. And then, using the model that it already has, it will be able to use your vectors to provide the correct answers. Now, there are two problems with that. The first problem is you probably should be a data engineer to do this stuff. I mean, you can go by just monkey typing the commands from some tutorial, but you'd better understand what you are doing, and the people who understand what they are doing are data engineers, which I'm not. The other problem is there is no public access to add your own plugins to ChatGPT. You can request access. I requested it when it first announced a year ago, and I'm still on the list. So even if I do want to bother with the vector database and all this shit, I cannot deploy the plugin anyway. Now, what we can use is the third-party services. And the one that I tried reasonably successfully is called Mantium AI. Mantium AI encapsulates all this for me. So what it does is, it says like, give me the data, I'll upload it to my own vector database, and then I already have a plugin for ChatGPT. You just need to tell me who you are, and then I will able to give you the information from your vector database into your ChatGPT conversations, which is pretty awesome, and it actually works. So again, here I go into the demo, and it actually shows some relevant stuff. And what it shows is the stuff that I already spoke about, like caching, local and remote, like parallel testing, local and remote, the test distribution, predictive text selection, and evil flaky tests. So also like watching the build with observability. And once I fed all this documentation to ChatGPT with the third-party plugin, it actually started give me very good recommendations of what to do with actual code samples that I just copy-paste into my build, and it actually does the job. And I took my build from 2 minutes to actually with all the optimizations to like about something like 5 seconds, which was pretty cool, pretty impressive, right? So, and just a couple of recommendations, stuff that you can do today for free in your build, parallel local caching, so parallel local running, like we did with the tests, local caching, remote caching. Remote caching is also free in the Gradle build tool, but if you want to use it, you need a node that will actually host the caches that it will be distributed. And this node is just a Docker container, so if you have an infrastructure to run a Docker container on your infrastructure, you can just, Docker image, and then you can run Docker container on your infrastructure. If you're already going to invest in the velocity, it actually comes with the infrastructure to run remote caches. And build scans. So build scans are the observability part in which you can actually send your, after each and every build, all the information about it is sent to Gradle servers, and we give you a unique URL with all the information about your build. How long it took, why, performance considerations, what's not, and it's all free and you can start using it today. So actually when you go to speak.in.j Baruch and go to the session and then just go to the Maven and Gradle challenge, it uses the build scan to show you the results actually. And another free that you can do is win prizes, doing the speed challenge. Okay, it's all come together, right? And what your company should pay for is the velocity or similar tool, if you can find one. And with that, that was the talk about ChatGPT. And that's all. Basically, what you missed, if I did it the full time, is me running the commands from ChatGPT, first failing, and then using Mantium actually succeeding. Everything else you get. But it is fun, especially when it fails. Okay, thank you very much. Okay, questions about this, about previous one, about, yeah.
Just a general comment about AI in general. A judge recently in the US declared that work of art that was produced by AI cannot be copyrighted.
Yes.
So it's automatically public domain.
Yes, which is very cool.
Yeah, it is interesting. Now that also means that if you're going to cut and paste like code that's generated by AI, you better not tell anyone that it's not yours.
Yeah, because it cannot be copyrighted. It can become a public of your IP. Yep. Oh yeah. Yep. Anyone else?
But
Any questions?
There's also lots of it's much deeper than this.
It's a whole new world. I mean, it's so many questions that were completely irrelevant just a couple of years ago, and now we kind of have no idea where to even take it. It's extraordinary. It's really, really cool. Also very scary, but cool. Okay? So we got 2 talks in price of 1. How cool is that? Which is also free, which is also even cooler.
You keep mentioning like we're Maven shop.
Yeah.
For better or for worse.
Works with Maven same way.
Velocity works with Maven?
Yep. Same idea.
That's good. And you should mention Quarkus.
All right.
Because I'm assuming you know like Quarkus, like, I wanted to try testing.
Now I understand your t-shirt.
Yes, here you go. And that's exactly the idea. Yeah, I'm going to turn it off.